All right, so I'm going to talk about something a little bit different here today. We are going to talk a little bit about row-based access control in ClickHouse, and it's something that I'm kind of excited to talk about because I haven't seen many people talking about how they can actually secure access to the database when they're building something multi-tenant. So once again, I'm Alan, the co-founder and CTO at RunReveal. And I've been an avid ClickHouse user since basically since 2016. At Cloudflare, I was around when it was open sourced, and we sent the blog post around at Cloudflare, and everybody got really excited, and we just started playing with it. And I was on the data team there, so I got exposed to it, but eventually I went to Twilio and brought it to Twilio and got to play around with it some more. I built product observability there. But now I'm building RunReveal, which is a security data platform. And we are trying to help security teams detect threats with AI. So essentially what RunReveal does, just for context, is we connect with first-party sources, things like your Google Workspace logs, your CloudTrail logs, your system logs, and we ingest those all into our platform. We have just a proprietary system that normalizes the logs into a standard format. Then we enrich them, we filter them. We have pipelines that help you manage them, so you're not paying an obscene amount for the logs that you're ingesting but not using. And then we do detections. So we help teams with detection and response. So you can build out detections in Sigma or in SQL, naturally. And something that we felt was really important to us was to be able to support this multi-tenant architecture for our customers. And the reason why we wanted to be able to do this is because it's really important to us. My co-founder Evan and I, we worked at Cloudflare and we worked at Segment together. And both companies had a product that you could just start, like sign up for free and start using. And we saw how powerful that is as a concept, because as a user, a lot of times you just want to start using it and make your own decision about whether or not it's something you're going to find value in. And so that's really challenging when you're building a logging product that has to scale to hundreds of millions of events per second or billions of events per day. Now, we're not like, RunReveal is still pretty small. We're not Netflix scale, we're not Cloudflare scale, but we're very confident that we can scale to that level. But there was one small roadblock as we were getting started, and that was just being able to support that free tier in a multi-tenant architecture on ClickHouse. So before I go any further, I wanted to talk a little bit about our architecture just for context. It's very simple. We have our ingestion processor, which we call RRQ, RunReveal Queue. And what it does is it goes out to S3 and it pulls log files stored in S3. And among other types, we also do API polling. So if we want to go out and connect to something like Slack, which doesn't export their logs to S3, we can pull their API for logs, primarily audit logs in this case. Or we can ingest them via webhook, and so that's where somebody is pushing logs to us. We then ingest them in our ingestion processor and insert them into ClickHouse in an optimized, well, obviously it's optimized format. I usually say that to other people who are not at a ClickHouse meetup, but the reality is we're leaning on ClickHouse a lot for being able to both ingest the logs at scale and query them at scale for things like detections and for AI workflows. And so then we connect to it through the API and people can query it. And that's really kind of a key piece there, is we're separating the writing from the reading, partially for scalability, partially for security. But the main idea is that we want to be able to read those logs out of ClickHouse as quickly and as securely as possible. The naive implementation of this might be either creating a user for every single workspace that you have on your platform, or in the most naive case, you might be just injecting a where clause that has like your workspace ID or your customer ID, and trying to kind of finagle what it is that your queries are going to run. Maybe you have like a filter that says don't allow insert or alter statements. But the reality is that's not really a scalable or secure solution. So it doesn't really work, because if you wanted to create, well, the latter one, obviously it's like, it's an implementation that can work for some companies at some scale. But if you really want to start doing things more securely, you might reach for managing users individually and then creating a new connection for every user. But then you have to either manage the passwords or the authentication. You can't actually switch the users on a single connection. So you have to literally make new connections. And because of that, you can't use connection pools in your whatever library you're using to connect to the database. And connection pools are really what give you a lot of that like big pipe efficiency and being able to load a lot of data. Fortunately, we use Go, and the ClickHouse Go library is pretty amazing. So we don't have to worry, like the connection pool is kind of built in. But the thing that I wanted to do, or that we were exploring, is actually implementing row-based access control. So ClickHouse has this is another example of how this actually works in practice. So if you are like trying to use users, you can't switch from user A to user B inside the same connection. You have to like disconnect and reconnect. But if you are using an individual connection, you can switch roles at will as much as you want. So in this case, you can select just the logs from workspace 1, 2, 3. And then on the next connection, you can set your role, or on the next, you're pulling the connection from the pool, you're submitting your next query. Before you submit the user query, you can set the role to workspace 4, 5, 6, and 4, 5, 6 won't be able to see workspace 1, 2, 3 roles, or logs. So this works pretty great in practice. It is a ClickHouse specific feature. I don't know that this is necessarily supported by a lot of other databases, but it gets us that, that property that we want to be able to put all of our customers' logs who are running in SaaS into a single database and have them not able to see each other's data, which is a pretty important property for a security company, naturally. The one thing I will say, though, is a big reason why we wanted to do this, or it was kind of like a non-starter. We wanted people to be able to run SQL queries directly on the database. And this is something that we're kind of shifting away from how other security companies think about this. A lot of other tools like Splunk, like Elastic, like you name it, they have like custom query languages just to be able to query the data from your logs. It happens in observability too, and there's nothing really against that. But as like people start to become wise to big data tools, SQL has become something of a standard in terms of accessing data at scale. And so it was really important to us for people to be able to run raw SQL against their own logs inside the database. And so we gave it a shot. So how might you do this? So this is a very simplified example of how you actually define a role and assign it a row policy. You simply create the role, you create the row policy, and then you grant that to the user that you're going to be connecting to the database with. And it's important to note that this user that you're using to connect to the database, it should be read-only. It should only have read-only access to the table, because if it doesn't, and this is pretty well pointed out too in the docs, it kind of defeats the purpose of using the row policy, because then the user could alter the database or alter what's in the table and kind of circumvent the protections there. But once you have the role policies in place, whatever is being returned from the table will have that enforced. And there's a couple important things to keep in mind as we're thinking about how to implement this. But the result is that we have one pool, one table with many different tenants inside it, and they're not able to see each other's data. Okay, so the way that we create them in real time, so that previous example was a little bit static. The way that we create them in real time is when somebody signs up with a new workspace, we actually go and dynamically provision this role. We give it access and define the row policies for all of our tables. And then we grant that to the single user that we're using to connect from the API to the database. But there's one important thing that we need to keep in mind as we're building this, and that's it has to be secure end-to-end, right? So we can't let anybody actually define what that workspace ID is, otherwise they might be able to read somebody else's roles, right? So an important property of this is that we actually pull that workspace ID from the auth context itself. So in our API, what we're actually doing is we have, it's a pretty typical API. It's just an HTTP API where you can set the auth headers. We have many different ways of authenticating, but all of those authentication methods are going to resolve to a user, and then that user belongs to a particular workspace. And so when we actually complete the auth, we have a definitive workspace ID on the user. So then from that user is going to have a role, and then that role we can use to actually enforce the row policy on the query. And so the result is that the client can't actually access any workspaces that they're not supposed to. We wanted to make sure that this was absolutely bulletproof. But before I get into some discoveries we found when pen testing our own software, this is essentially how it works in Go. Fortunately, we're written in Go, so ClickHouse has really good support for that. Cloudflare is a big Go shop. They contributed a lot to the library, but now it's maintained well internally. But this is essentially how it works internally is we pull the workspace from the request context, we set the role before running the user submitted query. So here there's no possibility for you to be able to change the role before running the query. And you can't change the role inside the query either. So one thing that's important to note, though, is we don't actually allow the users to have database shell access. This is all done through our API. So you have to access the query or submit the query through the API so that we can enforce this at this level. Yeah, but then the authentication parameters define the workspace and we're good to go, or so we thought. When we started implementing this, we got a little bit of a surprise. We were combining some fun features of ClickHouse, and we were trying out this new role-based access control, and we were running some queries in our workspace, and we are actually just developing this product, and we switched workspace contexts and we realized the data looked kind of funny. It looked kind of similar to the workspace we were just in. And so we did a little digging and we found out that roles, we found CVE 2024-22-412, which is my very first CVE ever, which is kind of nice. But the bug was essentially that when the query was being cached, the query itself was in the cache key, of course. The user was in the cache key, but it didn't actually include any role information in the cache key. So anybody who's using this type of authentication mechanism or authorization mechanism is going to run into this if they have any two queries that are the same. And it turns out when you're building a lot of dashboards and widgets, you're going to be submitting a lot of the same queries for your UI. So we submitted this to ClickHouse. The ClickHouse team was very, very accommodating. They helped us come up with a fix together. And then when they released the patch and had it deployed everywhere, we were able to disclose it, and we're all happy. That being said, we don't use caching anymore. Not that we don't believe in it, it's just it didn't actually turn out to be that big of a benefit in a lot of cases. So we decided just to ditch it entirely to reduce our surface area. The impact was pretty low. We caught it very early before we even deployed it to customers, so it didn't affect us. Hopefully nobody's running a ClickHouse that old anymore, so, but it was fixed in 24.1. We found it in December, reported it in December, and it was out, I think, by February or March. So it was just a couple of weeks. It was kind of hairy, like whenever you're dealing with cache bugs, they can be kind of difficult to fix. But the fix essentially is now the cache key includes the roles, which is natural, and it preserves the security properties. So we're pretty happy with that. We're happy with the ClickHouse team and how they responded to it, and they were very helpful throughout all that. So that's the security aspect of it. There are a couple of things that you need to keep in mind if you want to actually implement this. And one of the biggest ones is that if you're going to use this feature, then you absolutely want to make sure that whatever it is that you're using as your tenant ID is in your primary key, is in your sorting key, and it's probably got to be one of the higher cardinality ones. So that means one of the first ones in your long primary key, whatever you're using, because that is going to be used in every query if you're using it, right? And so this is how you can start to debug it, though. You can see that if you use this set role feature, this role assumption feature, what it will do is you can debug it and see that it's actually applying the condition, the where clause of whatever it is that you're doing your row policy based on. And so for us, it's workspace ID, and it says condition workspace ID in the workspace. I don't know why it has 2 in there. I've never really dug deep into that. I'm sure it's a really interesting story, but we've got a lot of things that we're building at RunReveal, so I haven't had the time to look into it. But it's pretty cool, and it's really useful to be able to debug it at this level because sometimes you get curious and it's not really, always performant. In some cases, we found that, and we haven't really found a good, repeatable thing that is good enough for a bug report, but set of conditions, I should say. But sometimes we notice that the predicate isn't pushed down, and that means that it's not necessarily going to be as performant. It can do a bigger scan and then filter afterwards. So we're still trying to figure out why that is. But sometimes this can be improved just by simply putting in a pre-where instead of where. So we're still kind of working through that. Another big gotcha of this is there's a default deny policy for any table where you apply a row policy, which means that if you have a user that does not have a policy attached to that user to be able to read that table, then they won't be able to read anything. And if you do select star on that table, even if they have permission to select from that table, they won't see anything and there will be no errors. So it's important to keep in mind that if you are going to implement this, you want to grant every user who is going to read that table a row policy of some sort. And you can even make a row policy that allows them to read all rows with something like where 1 equals 1. Or you can look at this setting, which is relatively new, that allows users without row policies to read rows from that table. So generally, though, I think this is a pretty good approach. I'm always in favor of the secure approach being the default and the right one to go with. But when we were getting started, it was just kind of surprising that our admin user, our default user, couldn't read that table after we had applied this. So just something to keep in mind. You can always use the explain with index is equal to 1 to see what's happening and understand what's going on under the hood. And I'm sure there's some fancier debugging you can do with the explain too. Performance-wise though, it's negligible in our experience. In fact, because we have that in the primary key, it just effectively is like making sure that we're using some part of the primary key for every query. But it's hasn't been an issue for us, and we're really satisfied with the results. So at scale, the architecture wins that we get are we have kind of an end-to-end mandatory authentication when querying these tables. We only allow API level access, so that is one of the properties that enables this. If we enabled shell access, that would open up a whole can of worms that would create some interesting challenges for us. But right now, we're just allowing individual queries, API only. It works great. The other thing, just by the numbers, we're inserting billions and billions of rows daily. Millions of rows can be scanned every query and across thousands of workspaces and dozens of concurrent queries. So nothing like Netflix, but still pretty impressive that it doesn't really have any impact on the performance. But what did we learn? Really just like learn your systems, understand them, implement things securely by default, and just try and make the secure path the only path or the best path, certainly the easiest path, and check it out. It's a pretty cool feature. I really love it. Our customers are thrilled that they can run arbitrary SQL against their logs, which is something that isn't really common. And we have the confidence that it's going to be secure and people's data isn't going to be leaked. So thank you. Yeah, we write, the writer itself is actually multi-tenant. So the writer is consuming everything from all our customers, right? So in the pipeline itself, customers don't have permissions to execute anything. We're just consuming based on the configuration that they've given us from external APIs, external inputs. And we do the normalization and everything. And then we insert into ClickHouse as a single user. So that writer user has permissions to insert into those tables at a broad level, right? And so we don't have to worry about that at all because we're not using the same user role that you need to read it. Does that make sense?
So the writer is per tenant, per user? Or
No.
Your company has the writer?
Yes. The writer is like a very privileged user that can write the entire table or any tables for that matter. So the question is, how do you ensure that the set role is not injected into the query? We have only allow a single query to be run. And we are also filtering out that particular query using just dumb, string comparison. But even still, like that's an extra layer of security since you can only run a single query at a time. Even if you could run set role, you couldn't run anything else. So the connection would reset and you would have to submit another query and it's not going to persist. Does that make sense? Cool. Yeah, great question. So the first question was, for noisy neighbors, how do we deal with noisy neighbors on RunReveal? And the reality is noisy neighbors can absolutely be a problem with this architecture. It is, we have various deployment models. We actually encourage our customers to use the bring your own database model, which gives them a dedicated instance, ClickHouse instance, ClickHouse cluster for their users. And we think that's kind of a nice compromise so that they can scale out, scale in as much as they want and deal with the performance implications of that. And so most of our enterprise customers, we are kind of gently nudging towards the bring your own database model or the fully on-prem model because noisy neighbors can be a problem. So, but for the multi-tenant SaaS, it hasn't actually been that much of an issue because we use ClickHouse Cloud, and ClickHouse Cloud has great horizontal and vertical scaling and auto-scaling. So noisy neighbors can be a problem, but most of the time we're just going to either scale up or scale out. And in practice, it hasn't been that much of a problem. It remains to be seen how long that will last, and I'm sure if we had some malicious actors get on the platform, then we would have to like respond and figure out what to do in that situation. But we do monitor like query runtimes, we monitor the performance, we monitor the insertion lag, we monitor like a dozen plus different things to make sure that everything's staying snappy and performant. But it's absolutely something we have to be considerate of when running a multi-tenant platform, and make sure that people are like bounded by their whatever it is they're trying to do. Now, one more thing I want to say about that, and then I'll move on to the next question. ClickHouse does have performance policies that you can apply, limits that you can apply to the user. And I believe there are some pretty sane defaults, like just the amount of memory that you can consume, the runtime of the query, and stuff like that. So there are some limits in place in that regard too. But of course, like you always have to be thinking about these things with these complicated big systems, and we are too. So the other question real quick was, oh, right. Yeah, so I kind of said it already, but we're using ClickHouse Cloud. It's only a single shard. It's running on object storage. So like there is no blast radius to contain there. If it's affecting anybody, it's affecting everybody. So we don't partition at all, actually. So for the same reason we don't shard, we're running on ClickHouse Cloud. Partitioning doesn't actually provide you much benefit when you're able to run on ClickHouse Cloud, because you are artificially limiting the size of a part, right? So when you do that, then you can't like merge two partitions that maybe could have been merged. That being said, like it's neither here nor there in practice. The big benefit that you get from just having it as a high order in your primary key is just that all of a customer's data is going to be like temporally local as well. So in practice, like, in fact, that's something that helps with the performance and the blast radius, is if there is some piece of the data that is not performant or some block on a disk somewhere gets corrupted, it's only going to affect likely one customer or a few customers. So yeah, but great question. Thank you. The first question was, this is essentially IAM. We have users that are accessing the service, but does it support things like service principals? And so in our case, like, we don't have that big of a distinction between a user and a service principal. Like in our mind, they're kind of similar concepts. It's just whether or not there's a human identity on the other end. And so at this layer, yeah, you can do the same and there's not really any issues. In our API, we would provision like an API user or an API key, and that's kind of like a distinct service principal in our model, and it works just the same. Data in transit is authenticated just by the API, so that's kind of above the ClickHouse layer, aside from the responsibility of ClickHouse. So it's really up to us, being that API layer, to enforce that authentication contract and make sure that it doesn't cross any boundaries or do anything like that. But yeah, absolutely. I mean, like, it depends on what level you're talking about for securing it in transit. But like for us, between the API and the client here, like that's authenticated by us, that's authorized by us, that's absolutely. You have to use TLS anywhere. Everything in this diagram has TLS. We have no HTTP anywhere. Like, Go is really great at managing certificates. Nobody should be using like any sort of plain text anymore. Sorry. What is the API? We run everything in AWS, and the client can be any client that's submitting an API request to our API. Yeah, that's a great question. So like creating a table per customer, for example, or creating a database per customer. Great question. That's actually something that we considered very early on, being able to create like individual unique tables for every customer, and then we could just grant access at the database level or at the table level. But ultimately, there's a lot of overhead in that itself, right? So having a multi-tenant ingest pipeline allows us to batch many customers' data inside a single insertion statement to ClickHouse. Whereas if we had individual databases or individual tables, then we have a lot of tiny batches coming from a lot of tiny customers that are free customers who, you know, ultimately the marginal cost, we need to minimize that marginal cost. And anytime we're doing small inserts like ClickHouse, for those who don't know, ClickHouse doesn't like small inserts. It likes big, chunky, like 100,000 plus lines before you can actually insert. At least efficiently at scale, we're talking like, we want to be able to scale to millions, billions of events per second. So that's the main reason, is just like complexity and overhead. But it's certainly something we considered, and probably is something that works for a lot of other architectures if they're if it fits your use case. So I highly recommend doing that if that's the use case. So yeah, deletions. So the question was, how do we handle deletions in this use case? Deletions are still admittedly a bit manual, and that's really just a consequence of the big data architecture, right? Deletions aren't cheap. Deletions are done like mostly at a workspace level in our use case. So if a customer offboards and they submit a request for deletion, we'll delete all their data, we'll be done with it. But that's something that like it's done at an administrative level, not at the user level, so people can't submit delete queries, right? And in particular, what we're building a SIM, a security information and event management system. And the expectation is that they're not able to be deleted easily by anybody. So in that case, like once we're big enough, we'll probably make a deletion API for admins. But right now, like we just kind of handle it through support requests. So cool. Well, thanks everybody. I hope you enjoyed it.